to you about some of the odd things JavaScript does to us with variables. And since a lot of us transition into JavaScript from another programming language, maybe we start working on the UI a little when we're doing a lot of back-end work, and we learn on the job, getting things working. Sometimes we skip those fundamentals. Even if we do have an opportunity for some training, oftentimes that training is framework specific, and we still don't get those JavaScript fundamentals, or we've just forgotten them because it took so long for us to get to code complicated enough to get some weird behavior. So my name is Julka. I'm a principal software engineer at Framebridge, where we are a startup in Georgetown disrupting the custom art framing space. We get to work on problems for both e-commerce and manufacturing. All right, and let's jump right into some code. So I'm going to talk to you today about scope, a lot about scope. We're going to go over some types of functions in JavaScript. We'll talk about hoisting and closure, as well as some weirdness around arrays and objects. Most of my examples are going to be ES5, but bear with me. There's going to be a lot of var. The concepts I'm illustrating with var will lend themselves very well to the slight differences between var and let and const, which I'll talk about when I get to ES6. So here's a little bit of silly code for scope. I'm just going to set up a variable called pink, the value 1. And then I can take a look at the value in pink and get 1. And I've got window.pink, and that's 1. So here, the difference here is I'm now saying var fuchsia, and I can take a look at fuchsia, and I get that value 2. And I've still got window.fuchsia with the value of 2. So no differences so far, right? This is in part because we're dealing with one scope. In order to set up some examples, some contrived examples with multiple scopes, I'm going to use functions. Now there's two different kinds of functions in JavaScript. There's these named functions that will look like function pair parens for our parameters, and then the code that executes, and there's anonymous functions, where the var pair part here is optional. And we have a function here without a proper name and the code that executes. So most of my examples won't be doing this part. We'll just be doing what's called immediately invoked anonymous functions. And they look like this. So here's our function with the parentheses for the parameters. And then in between the curly brackets, we'll have the code we want to execute. After that, we do another pair of parentheses to say, I want to execute this function now. And then to make our browser happy, another set of parens, and then semicolon. So there's going to be a lot of this in the following slides. And here's the first one. So here I've got my first anonymous function that is immediately executing. And I go in there and I set up magenta as a value of 3. Then I can take a look at the value of magenta, and I get 3. And then window.magenta, and I have 3. When I come outside of this function, magenta is still 3. Window.magenta is still 3. So still nothing's changed. But here's where we start to get a change. So the difference here is I'm now saying var rouge is 4. And then I can take a look at the value of rouge, and I get 4. If I ask for window.rouge, I've now got undefined. So things have changed. And when I come outside of this function, again, if I ask for window.rouge, I'll get undefined. If I try and use rouge itself, I'm going to get a JavaScript error, and my code's going to stop executing. So why does this happen? And that's because of that var here. When we're using var to set up a variable in JavaScript, we're saying that that variable should only be available in my current scope, this function, and child scopes. So I could have more functions going on in here that would still have access to rouge. But it's not going to be available to me in parent scopes, which is the code that's running down here. And so I can use rouge as much as I want inside that function, but as soon as I get out of it, it's not available anymore. And properties on window are oftentimes variables that have bubbled up all the way to our global scope. It's a bad pattern. It's an anti-pattern to depend on that. But it's important to understand what's going on and why you sometimes end up with these things on window. So here's a more complicated example, the same thing. Here's my first immediately invoked function, and then I'm going to set up blush to be 5. I'll take a look at the value of blush in yet another immediately invoked function, and I'll get 5. Here I can change the value on blush to 6. And if I take a look at blush, I've got 6. I'm getting ahead of myself. And then I'll set up var rows to be 7. And I can take a look at the value of rows and use that, and I've got that 7. Now I'll come out of that function into its parent scope, And down here, I can take a look at blush and get that 6 that I set up here. Down here, if I try and use rows, I'm going to get that JavaScript error again because rows is only available to me in this function because I set it up using var. So that rows variable is only going to be available to me in here and its child scopes. It's no longer available to me up here in the parent scope. And then I can come out of these two nested functions entirely. And if I try to use blush, I'm going to get that JavaScript error because blush, again, has var up here. So it's not getting into my parent scope. And that parent scope, that will keep bubbling up until it hits the place that actually defined that variable with var. So rows will also give me the JavaScript error, just like it did in the previous line. Right, and this becomes important to us when we're dealing with JavaScript frameworks nowadays because we're often dealing with function inside a function, inside a function, inside a function, turtles all the way down. We don't necessarily know the scope tree that we're dealing with and how the code we're writing right now relates to some other code. We're unintentionally putting things in our parent scope. We can overwrite things we weren't expecting and create bugs that are really difficult to track down. Are crimes against JavaScript. All right, so here is another var example. So I'm just going to throw an if true, as a little if statement in there, and set up maroon here as 29. I can take a look at maroon here and get 29. And down here, outside of this if statement, again, I can take a look at maroon and I'll get that 29. That's because var will scope to its parent function. And if is a function. So it is going to find its way outside of that if statement. Okay. All right, here's one more. I'm going to set up var terracotta to be 19, and then I'm doing a named function here, blaze. I'm setting it up, and then I'm calling it. And when I call it, I'll get here to this console log, where I am taking a look at the value of terracotta. What do you think we're going to get here when we look at terracotta? I'm hearing some 19s, I'm hearing some undefined. Maybe I heard some 20s. So this is a trick question. And I'm setting myself up to talk to you about hoisting. So when our browser gets JavaScript, it does multiple passes over that code before it executes it. In that first pass, what it does is it will find all of these var terracottas, any variable where we're using var, let, const, when we're setting it up. So it will find those, and it will split them up. So this code turns into this. It takes the var terracotta, and it brings it up to the scope for that variable. So it brings it up to the top of that function. And then it lets the rest of the code execute. It leaves the terracotta equals 20 down where we had initially set up terracotta. So when we call blaze, and we make it to this console log, terracotta has been initialized, but we haven't actually put anything in it, so it's undefined, and we'll get that undefined. We can then go on to put a value in terracotta, and if we use terracotta somewhere down here, after that, we get that value 20. All right, so we talked about types of functions, the named functions, and then anonymous functions. Named functions do some interesting hoisting. So here is just a silly little function. I'm setting up a named function called chocolate, and I'll just console log out, yes, please. But before I've actually set up that function, I am going to execute my chocolate function. What do you expect that will have happen here when we execute chocolate?
Yes, please.
We're actually going to get that yes, please. And here's why. So we talked about that first pass that our browser does over the JavaScript code where it hoists those variables. With named functions, it does a second pass. So in that first pass, it will find that named function and set up a variable for it in that scope. So it'll bring up a var chocolate up with those other vars at the top. On the second pass, it will pull out the definition for that named function and bring that just below all the vars. So that's when we'll get this. This is still a little different than anonymous functions because the browser isn't actually going to go inside that function and evaluate what's going on in there yet, but it will bring it up and define it up here. And then it'll get to the code that we wrote where we actually executed with the chocolate. So this has flipped what we've written and added more code. What we wrote was execute chocolate, and then let's define what chocolate does. But it has flipped it on its head and added some stuff. All right, closure. Closure is a common CS concept that we use a lot in lots of programming languages, and we're using it more and more in JavaScript. The basic idea is that you have some functions and some properties that are only available in limited areas. They're closed off with limited access. In many programming languages, we might do this with private methods or protected items. And in JavaScript, we use scopes to do this. And so here's a really simple example of closure. Up here, I'm setting up a marmalade variable, and that's a function. Inside that function, whenever that function executes, it's going to set up a caret and initialize that to 0. Then we set up greater than 2, which is going to be another function. And what greater than 2 will do is it'll go in, it'll increment caret, and then it'll return us a boolean comparing caret against 2. So if caret is greater than 2, we'll get a true, otherwise we'll get a false. And then it returns that function greater than 2. So down here, I can say salmon equals what we get back from marmalade. And what that means is greater than 2 will now be available as salmon. And through all of this, we're not going to have any direct access to caret. So I can come in here and call salmon, which means I'm going to call greater than 2. I'll come in here, and caret is 0, but I'm going to increment it, so caret is now 1. 1 is not greater than 2, and we'll get back a false. We can go through again. 1 will go up to 2. 2 is not greater than 2. And again, we're going to get a false. And then on the third try, now we've got 2. 2 goes to 3. 3 is greater than 2, finally, and we get a true. And through all of this, we're doing things that have an effect on caret, and we're depending on caret for our outputs, but we don't have direct access to caret through salmon. All right. JavaScript is object-oriented. Everything we deal with in JavaScript is an object. We have string objects with properties like length and methods on them, like substring, where we can get just a little bit of the content out of that string. But JavaScript treats some objects more like objects than others. With a string, like the string of yellow, we can ask for the type of it, and we'll get string. We can ask for the type of 7, and we'll get a number. The type of true, and it's a boolean. So these are string objects, and number objects, and boolean objects, but we call them strings and numbers and booleans. Here I'm going to ask for the type of an empty object. So these curly brackets are how we set up objects, and they're empty, so it's just an empty object. I'm going to get object. I can also ask for the type of an empty array. Square brackets, an empty array. And here I'll get object. So there's array objects and there's object objects. And we treat them very similarly. We treat arrays as object objects. Great vocabulary, right? Really clear to understand. If you do want to know whether the object you're dealing with or whatever variable you're dealing with is an array, a nice way to do that with vanilla JavaScript is just array.isArray, and then you pass in the thing you're testing as a parameter. So here I'm passing an empty array, and that'll give us a boolean. So here we get a true. Right. I'm going to set up an object. I've got canary, and it has 2 properties. The type is bird, and flies is true. But I also want bumblebee. So I'm going to say bumblebee equals canary. And bumblebees can fly, but they're not birds, they're insects. So I'm going to say bumblebee.type equals insect. What do you think we're going to get out when we take a look at the value of canary.type now? Hearing lots of insects. And you've got it. We're going to get back insect. And that is because when we deal with these object objects, we are dealing with them by reference instead of by value. That means that the thing that we're storing in canary is a reference to where that object is. It's not the object itself. So canary is a pointer to where this object we set up is. And when we say bumblebee equals canary, we're copying that pointer and putting it in bumblebee. So we've got two variables, canary and bumblebee, and they've both got the same value, a reference to this object. And so bumblebee.type is going to take that reference to that object and find the type property and change it to insect. But that reference is the same as the canary reference. And so we end up doing manipulation on the same object in two different variables. Arrays work the same way. All right, let and const. We can use let very similarly to the way we use var. And so here I'll just set up a variable green with let. So let green equals 21, and then I can change the value to 22. With const, the idea is that that variable is constant. It's not supposed to change after you set it. So const stage equals 23. If I come along and say, well, now I want stage to be 24, I'm going to get a JavaScript error because I just changed something I said I wouldn't change. This has an interesting effect on those objects. All right, so I'm going to set up a const line, and it's going to be an empty array. So line is really a pointer, the reference to that array I'm setting up. And then I can do line.push 25, so I'm going to add the value 25 into that array, and that's okay. I can do that because line is a reference to where I have an array, and I'm going to use that reference and then a function on the object that it's pointing to and add in that 25. I can take a look at the value on line, and now it is an array with one item in it, the number 25. If I come along and say line now equals an array with the value 26, I'm going to get that JavaScript error here. What I'm doing here is I'm setting up a whole new array in this part. Setting up a new array with one value in it, that's 26. Then I'm taking the reference to that and putting it in line. And that's when I'm actually changing the value of line, which I'm not allowed to do on a constant. I could instead come along and remove the items from line and add in 26, so that's what I want line to look like now, but I can't set it up as a whole new object with const. All right, here is another difference between var and let, or the difference between var and let. So I had a similar example with var with an if statement. Here I'm going to say let olive equals 28, and go to an if statement, so a little if true statement. I'm going to say let olive now equals 29. And if I take a look at olive here, I've got 29. And if I come out of this if statement, olive is now 28. With let, we're scoping to the nearest code block. That might be the parent code block. That might be the parent function, but it isn't necessarily so. So the parent code block here is this if statement. And so that's going to be the scope of this olive here. And when we leave that, we lose that. And we fall back to the one we had before. Or if we hadn't set up let olive in the parent scope, we wouldn't be able to use olive here at all. So that is the difference between var and let. One is scoped to the parent function. One is scoped to its parent code block, which isn't necessarily a function. And this if true is silly. And in the F6, we can just get rid of it to set up code blocks wherever we want, if we want to do a bunch of stuff without accidentally spilling variables that we're not going to use later on into our scope. So here I can take a look at moss and get 37 and come back out, and I've got the 36 from earlier. This becomes especially useful when looping over things. So here is a for loop, and I'm going to set my iterator up with let. I'm going to say let emerald equals 30. If I come into here and I start looking at the output, on the first loop we're going to get 30, then 31, 32, 33, 34. After we console log out that 34, it's going to increment again to 35. Emerald is now greater than 34. We'll break out of this for loop and come down here. And down here, if we try and take a look at emerald, we're going to get that JavaScript error because that hasn't been set up. Emerald is scoped for that for loop up here. And so we don't have it hanging around after when we don't need it. And to contrast, here's that same code with var. We're going to get the same output, After the 34 is console logged out, it's going to increment emerald again to 35, then break out of the loop because 35 is greater than 34, and we'll get down here. And down here, we've still got emerald and it's at 35. So if we're depending on that variable elsewhere, it might have a different value than what we were expecting. All right, so we've gone over scopes and how they bubble up in JavaScript, types of functions and the different ways that the named functions are hoisted, as well as how JavaScript variables are hoisted. We've gone over closure and how arrays and objects are extra special. And we've gone into some differences with let and const. All right, so I hope with this you will be able to go back to your code Monday morning and have a little more thought on how you're using your JavaScript variables. Thank you for joining me today.